Okay, so in the last class, we have done cardinality of a set, and we have talked about power set. We have talked about the universal set, right? And the subsets also. So in the last class, we have done this exercise. So let us start with the Venn diagrams today. What do we mean by Venn diagram? How do we use it? And we have one more thing. We have to we have basically the operations on sets. Like in algebra, we have addition, subtraction, multiplication, division. In case of sets, we have union, intersection, difference of sets, and other things. So we are going to do this particular part in this class, right? So I will just share another screen. So I hope the screen is visible. Yes, Taisha.
So could you please speak a little louder? It's not very audible here at my place.
Okay, okay. So in the last class, we were doing uh, the second exercise. So let us start with Venn diagrams now, right? So what do we mean by Venn diagram? Venn diagram is basically a diagram used to show the operations on sets. So basically, what do we have here? Uh, the universal set is always represented by a rectangle. You'll draw a rectangle here, and at the right corner, upper right corner, you will write U, which stands for universal set, right? And then all the sets A, B, C, whichever set you have, it will be represented by a circle. For example, this is the first circle, so it is set A. This is the second circle, so this is set B. There can be many more circles. They will represent the set inside this universal set U, right? So this is how we represent it. So circles represents the set and the rectangle represents the universal set. So this is the basic representation of Venn diagrams, right? Now let us now come to the operations on sets, and we will discuss the operations on sets using these Venn diagrams also, right? So how do we draw them? What area does it represent? So that is what we need to understand. So let us come to this one, operations on sets. The next topic is operations on sets. So the first operation on set is known as the union of sets. Union of sets. So it is represented by union, as the word itself says. Union means you have to combine two or more sets, right? Union is basically the combination of many elements. So represented by A union B, like this. So it is represented by A union B, A U B, right? This U does not mean it is the universal set. It is the union, right? So there are two U's here. So represented by A union B. Uh, Let me give you an example here. For example, if A is a set having some elements like 1, 2, 3, 4, 5. B is another set which is having 2, 4, 6, 8. Right? So what do we mean by A union B now? So A union B is basically you have to write all the elements of set A and set in B in this set. So one, and whichever is repeating, you will have to write it once only. So 1, 2, 3, 4, 5, 6, 8. Right? So all the elements of set A are there in A union B, and all the sets of B are also there in A union B. You can see that. Right? So this is how union is represented. Now let us come to the Venn diagram of A union B. How do we represent uh, it through a Venn diagram? So the rectangle represents the universal set, and this is set A, this is set B. So if this is A and this is B, then the whole shaded region is considered to be A union B here. This one, right? So all the elements of A and all the elements of B will be there in A union B. So this is how we represent. So you will have to learn the representations of A union B and other operations by using the Venn diagrams, right? So this is A union B here. I hope it is clear. If you have any doubt in the example or in the Venn diagram, you can ask. Okay, so now let us come to the next one. The next one is called the intersection of sets. I hope this is clear. I'll just move to the next slide then. The second operation is known as intersection of sets. Intersection basically means the common part of both the sets. So it is represented by A intersection B. So intersection is basically represented by inverted U, right? तो ये इसका रिप्रेजेंटेशन हो गया. Example पहले हम कर लेते हैं and then we will go to the Venn diagram. So if you have A here, let us take the same example 1, 2, 3, 4, 5, and B is another set which is having 2, 4, 6, 8. These are the elements. So what do we mean by A intersection B now? A intersection B means you have to write all the common elements. You have to select all the common elements and you will have to write it here. So you can see that 2 is common in both, 4 is common in both. So only 2 and 4 will be there in the intersection part, right? Intersection is common part. Now let us come to the Venn diagram of this intersection. So the rectangle represents universal set. This is A, this is B, and the common part of both of these sets is the middle one. So this middle thing is called A intersection B, right? Because that's the overlapping part of both the sets. That is A intersection B. So I hope it is clear. Intersection is clear to everyone. And there is one more thing. Union is represented by and. Like we have done union here. So you can say A union B is also known as, or you can call it A or B. It is represented by or, right? Similarly, A intersection B is represented by and. If you have A intersection B, then it can also be called as A and B. So and basically means intersection, or basically means union, right? Now let us come to the third one. Third is known as disjoint sets. Disjoint sets. So basically, disjoint sets means any two sets or any two or more sets having nothing in common, right? So if A intersection B is pi means there is nothing common. So the set will become an empty set. Then we can call A and B are disjoint sets, right? And the Venn diagram, for example, if I give you an example here, let us say A is 1, 2, 3, 4, 5, and B is another one, which is A, B, C, like this. So you can see that there is nothing common in between A and B here. So A intersection will become pi, and therefore we can say that A and B are disjoint sets. And how do we represent it in form of a Venn diagram? So this is U, this is A set, and this is another set B. So there is no overlapping between A and B here, right? It means that there is no common part, and therefore they are known as disjoint sets. I hope it's clear to everyone, disjoint sets. Now let us come to the fourth one, which is called difference of sets. Fourth is difference of sets. The difference of sets means um, basically it is represented by either A minus B or B minus A. That depends on the question. Well, so, and let us understand this through an example. For example, if you have a set A, 1, 2, 3, 4, 5, and there is another set B, which is 2, 4, 6, 8. So how do we write A minus B now? The difference between the sets A minus B. So first of all, you will have to choose all the common elements in these. Common elements are 2 and 4 only, right? You have to eliminate these common elements, and whichever, sorry, not 6, it will be 4. So if you are talking about A minus B, you will have to write all the remaining elements of A now. So all the remaining elements are 1, 3, and 5. Right? Similarly, if we want to talk about B minus A here, you will have to write all the remaining elements of B. So B में जो remaining elements है, these are 6 and 8. Right? So whichever set is first, you will have to write all the elements, all the remaining elements of that set. I hope it is clear. First of all, you have to remove all the common elements. Then A minus B में हम A के बचे हुए elements लिखेंगे and B minus A में हम B के बचे हुए elements लिखेंगे. Yes, Aradhya.
Sir, what if there are no common elements then?
Then let us take an example for that also. Suppose if you don't have any common elements in between A and B. For example, we have 1, 2, 3 here, and B is another set which is 4, 5, 6, let us say. So there is no common element. So how will you write A minus B now? It will be equal to 1, 2, 3 only because there is no common element. So you will have to write all the elements of A now. Similarly, for B minus A, you will have to write all the elements of B because there is no common element. Right? And how
Yes.
will we represent it in form of a Venn diagram? It will be like this. So if this is A, this is B, and this is universal set. So A minus B basically represents all the elements of A except the common elements of A and B. तो कॉमन एलिमेंट्स को अगर हम ए में से हटा दें तो इसमें जो शेडिंग होगी इट विल बी दिस रीजन. ए में से हमने कॉमन एलिमेंट्स को हटा दिया विच आर इन ए एंड बी. So this shaded region is called A minus B. Similarly, B minus A का मतलब क्या हुआ? It will be removing all the common elements of B. Removing all the common elements of A and B from the set B. So it will be this set. So this will be B minus A. Yes, Taisha.
Sir, in the second example, what will be B minus A? How will it be 4, 5, 6? I didn't understand that.
See, B minus A means you will have to write all the elements of B except the common elements. And if there are no common elements, you will have to write all the elements of B then.
Okay, sir, got it.
Right? So this is how we write the difference of sets. And next is, I hope this is clear. So just a second, everyone. So now let us come to the next topic, which is complement of a set. Complement of a set. So, what do we mean by complement? First of all, it is represented by A dash, and sometimes it is represented by A raised to power C also, A complement, right? But usually we represent it by A dash only. And what do we mean by A dash? It is U minus A. Means you have to remove all the elements of A from U, universal set, right? So this is the basic definition of A complement. And if we represent it on a Venn diagram, it will be like this. This is U. Let us say this is A here. So all the elements of U except A. So you will have to shade all the region except the part of A. This one. This is called, the shaded region is known as A complement. I hope it is clear. एग्जाम्पल के लिए लेट अस से अगर आपके पास U एक सेट है यूनिवर्सल सेट विच इज फ्रॉम 1 to 10 and A is a set which is having 1 2 3, only 3 elements are there. So how will you write A complement? It is U minus A. So all the elements of U except the elements of A. So remove all the elements of A from that. So you will get 4 5 6 7 8 9 10. These are all the elements of U except the elements of A. Right? So this is how we write the complement of a set. I hope it's clear to everyone. So the general form or you can say set builder form to write the complement of a set is A complement is equal to X such that X belongs to U and X does not belong to A. Right? It will belong to U, but it will not belong to A. Yeah, that's right. So that is the that is the set builder form to write the complement of a set. So let us take one example and let us understand all these by using that example, right? So question is, you have a universal set which is uh, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P means the whole set of English alphabets, right? And then A is the set of all vowels, A, E, I, O, U. And B is another set which is the set of all sorry, consonants. Set of all consonants. The set of all consonants will contain, I think, B, C, D, F, and so on up to Z, right? So these will be missing from the set of all consonants A, E, I, O, U. Rest will be there. So now let us understand. First is we want to find out A union B. So A is the set of all vowels. B is the set of all consonant. If we combine them with each other, you will get the whole set U. A, B, C, D, E, F, G, H up to Z. And that is equal to universal set. Second is A intersection B. So you can see that A is the set of all vowels and B is the set of all consonant. Is there anything common in between these two? There is nothing common in between vowels and consonants, right? So A intersection B will be pi. Third one is, uh, are these sets disjoint sets? So yes, these sets are disjoint sets, right? The fourth thing is, um, A minus B. If we talk about A minus B now, because there is nothing common between these two, so A minus B will be equal to A only. A, E, I, O, U. Similarly, B minus A will also be equal to B only. That is the set of all consonants, B, C, D, F, and so on up to Z. Right? So that is the fifth part. And similarly, if we talk about A complement and B complement now, A complement is basically U minus A. So U is the set of all English alphabets. A is the set of all consonants. So U minus A will be equal to B. अगर आप सारे इंग्लिश अल्फाबेट्स में से सभी कॉन्सोन सॉरी वॉवल्स को हटा दोगे तो यू आर लेफ्ट विद कॉन्सोनेंट्स ओनली राइट so it will be B. Similarly, complement is U minus B, which means universal set में से हमें सभी consonants को remove करना है. So you are now left with A only, which is the set of all vowels. This is how we can find all these using the sets. Right? I hope it is clear how to write all these things. Okay, so we have a few properties also that we need to understand. One such property is known as De Morgan's law. And it is the property that belongs to complement of a set. So I'll just write down here De Morgan's law. De Morgan's law states that if you have A union B whole complement, then you can write it as A complement intersection B complement. Similarly, if you have A intersection B whole complement, then you can write it as A complement union B complement. Right? These are the two properties by which we can convert union to intersection and intersection to union using the complements of a set. Right? I hope it's clear to everyone. So let's, yes, Delisha.
I didn't understand this concept. Can you please make explain
De
it?
Morgan's law.
Yes, sir.
De Morgan's law actually are the properties of complements where we can see what we are doing here is we are changing union to intersection, right? Here it is union, but after changing it, it will become intersection if we open the bracket.
Yes, sir.
Similarly, we are converting this intersection to union here, right? If we
Yes.
open the bracket. So we can separate both the complements with both the sets, and union will become intersection and intersection will become union. So that's it.
So,
That is right.
so
That's it.
basically, so basically, its use is to turn union into intersection and intersection into union.
Yes, using complement.
Okay, sir. Thank you, sir.
Right. So that is called De Morgan's law. Okay, so now I will share the screen with you. Let us try the questions from exercise 1.3. I hope the screen is visible. So everything is given in the book also. You can read every thing from here in the book and you will be able to understand, right? All the figures are given, all the Venn diagrams are also given. So this application of set, we will do it in the next class. Right now, we are discussing the topics that we have learned so far, right? So it is exercise number 1.3 from question number 1 to 6. We will do it. So here, exercise number 1.6, find the union of set A and B, that is A union B, in each of the following pair. So let us understand this. First one is A is given 1, 2, 3, 7, and here it is B is 2, 7, 9. So union will be 1, 2, 3, 7, 9, right? Because 2 and 7 were there in both. So it will not be repeated again and again. You will have to write all the elements of set A as well as all the elements of set B as well. Similarly, here A union B in the second part, in the first one, A is A, B, D, E. Whereas in the B, it is the set of all vowels. So you can see A and E is repeating here. You'll write A and E only once. And the other elements will also be written in this order, I, O, and U. So you can see that all the elements of A are there, all the elements of B are also there in the set. Similarly, x such that x is a natural number greater than 5. Natural number greater than 5 means it will be 6, 7, and so on up to infinity. Similarly, x such that x is a natural number less than. So b को अगर हम roster form में लिखेंगे तो it is 1, 2, 3, and 4. If we take the union of these sets, you will get 1, 2, 3, 4. Then 5 is missing here. So 6, 7, 8, and so on up to infinity. Right? Before writing it, you will have to convert the set if it is given in the set builder form, you will have to convert it into roster form first, and then you can use it, right? Then in the fourth case, A is pi and B is this one, 2 root 2 minus 1 and 0. So if you will write A union B here, obviously A does not have any element. So you'll have to write only the elements of B. So this is how we can write A union B in the fourth case. I hope it is clear. Now let us come to the second one. We have to evaluate each of the following. So evaluate means में intersection का sign given है सभी में. So you will have to write only the intersection part. So here the intersection is the common part of both the sets. That is 1, 2 in the first one. Then in the second one it is I don't think there is any. तो ये या तो ऐसे लिख देंगे empty set या फिर phi लिख देंगे. Then we have GOAT and CAT. So there is only one letter which is common here, which is A. You can write, oh no, it is A and T both. You will write A and T both here. It is A and T. Then x as that x is an integer and x as that x is a negative integer. Integer or negative integer में क्या common होगा? It will be negative integer only. So the answer is x as that x is a negative integer. Right? So this is how we use intersections. I hope this is clear to everyone. Now let us come to the third one and erasing this one. Just a second. So the third is of the following sets are disjoint. So disjoint set means there should be nothing common in between these. So multiples of 2 and multiples of 3. First set is multiples of 2. That is 2, 2, 4, 6, 8, 10 and so on. And multiples of 3 are 3, 6, 12, oh, sorry, 9, 12 and so on. So there are many numbers common in between the multiples of 2 and multiples of 3. One is 6, then another is 12, then we have 18, 24 and so on. There are many numbers. So which means that it is not these are not disjoint, right? Because they have common elements in between them. Similarly here, you have to check whether there is common element in between these two second part में. तो e है but यहाँ पर e square है which is not common. Pi है और यहाँ पर pi by 2 है which is also not common. These are both different. Root 2 है, root 3 है, 0 है, 1 है. So there is nothing common. The intersection is phi. So therefore these are disjoint sets. Right? Then the third one is x is that x is a real number and x is that x is an irrational number. So I hope there is common between real numbers and irrational numbers. Real means real number contains all the rational and irrational numbers, and therefore the common in between these two is irrational numbers only. So it is not a disjoint set, right? Then we have to write a minus b in the fourth one. You'll have to first check or eliminate all the common elements. 1, 3 and 8 are the common elements here. And since you want to find a minus b, you will write the remaining elements of a only. 1 and 5 in the first one. Then we have 3, 0, 8 is the common element in both. So there is nothing left in a now. So it will be 5. A minus b will become 5 because there is nothing remaining in the set A. Similarly, 2, 6, there is nothing common in between A and B. So the whole set A will come here, 2 and 6, like this. right? I hope it's clear to everyone. Okay. I think last 1 minute is left. So we will continue